When the frequency of the carrier wave is changed in accordance with the intensity of the signal, it is called then frequency modulation. Here, this is a carrier wave, high frequency. This is a sinusoidal wave, low frequency, and contain information. That information is to be now contained in the frequency of the carrier. Okay, we have to superimpose, we have to attach this information in the frequency. If the sinusoidal is increasing, we increase the frequency. Okay, like this is increased frequency. If the amplitude of the informative signal decreases, then we have to decrease the carrier frequency accordingly. It again increases, we have to increase the frequency of the carrier wave. Okay, so the frequency of the carrier is changed according to the amplitude of the informative signal. This is called frequency modulation. The changes in the carrier frequency are produced by the audio modulating signal. The amount of change in frequency from the frequency of the carrier is 100 kilohertz, and this change is we have taken here that change is 30 kilohertz upside and 30 kilohertz the lower side. 100 kilohertz the original carrier frequency. Okay, if the amplitude increases of the sinusoidal signal, it will go to the plus side, 130 kilohertz. If the signal, modulating signal, informative signal amplitude decreases, it will go to the 70 kilohertz, to the lower side. It's just an example that the carrier frequency can be deviated plus minus 30 kilohertz from the original 100 kilohertz value. The central frequency is 100 kilohertz and the maximum frequency deviation is 30 kilohertz. We have chosen. Okay, you can choose the other value, no problem. The central frequency is 100 kilohertz and the frequency deviation of FM signal depends upon the amplitude of the modulating signal, informative signal. Now the second point which is important, the central frequency is the frequency without modulation or when the modulating voltage is 0. The C point is the audio frequency, that is the frequency of the modulating signal, informative signal, does not determine the frequency deviation. Okay. So let me take an example. We modulate 100 megahertz. Mega means 10 to the power 6. And that voltage is 1 volt. And modulating signal is 1 kilohertz frequency. And let the deviation is 25 kilohertz. We give a deviation of 25 kilohertz for this modulating signal. So that means the carrier frequency will vary sinusoidally, 100 plus 0.025, 100 minus 0.025 in megahertz value. At the rate of what? 1000 times per second. Mean because the modulating frequency is 1 kilohertz. If the amplitude modulating signal is increased to the 2 volt, we are making it double, then maximum frequency deviation will be 50 kilohertz. Instead of 25 kilohertz, we have to make the deviation. Okay, 100 plus 0.05 megahertz and 100 minus 0.5 megahertz at the rate of 1000 times per second. So once again, the carrier frequency was 100 megahertz, 1 volt amplitude. Modulating signal was 1 kilohertz, and maximum deviation we have chosen 25 kilohertz. Okay, so it means the deviation, the modulated signal will have the deviation upper side and the lower side 100 minus 0.025 megahertz, and the deviation will take place at the frequency of the modulating signal, which is of 1 kilohertz. Right, that means 1000 times per second. 1000 times per second. Now if the amplitude of the modulating signal is increased, we made it double, then we have to make the deviation also doubled. Like instead of 25 kilohertz, that would be 50 kilohertz. And upper and lower sides, the frequency variation will be then between these two limits, and it will take place at the rate of the modulating frequency, mean 1000 times per second. Now here this is a graph. Okay, and what the graph is showing is again a very important, because along x-axis it is the time, along y-axis it is the frequency. Now this is a central frequency of the carrier. Okay, it is constant, but when the modulating signal comes, then it starts varying, and its variation is sinusoidal, because our modulating signal is sinusoidal. And upper frequency variation maximum, this is maximum variation, Fc plus KES. ES means the signal. And lower side the variation is Fc minus KES. So this is the carrier frequency is varying now. This is the instantaneous value at any instant. This is the original carrier frequency. This is the frequency deviation delta F cos omega st. This is our signal, right? Modulating signal. Delta F is the deviation in the frequency. So this is how. So let the carrier frequency is equals to Fc, and this is a carrier frequency. The informative signal is added. So this is the informative signal, cos omega st. Omega s is the angular frequency of the informative signal. So, how the modulation technique is, we have to attach our modulating signal in the frequency of the carrier. So at an other instant, any instant, Fi is the modulated wave, which new waves which formed with modulation. So Fc plus Kes omega st. The signal is contained now in the carrier frequency. Maximum frequency deviation is Kes. The K is attached because Es cos omega st. That's a carrier, there's a signal voltage, and multiply K mean that becomes the frequency. So we're multiplying 2 pi, both sides, every sides, every term. So 2 pi f becomes omega. So omega I equals to omega c plus delta omega cos omega st. So then, by definition of the angular velocity, omega is what? D theta over dt. So having the value of d theta from here, omega into dt. So integrating both sides from the limit 0 to t. Okay. Then substituting this is omega is actually omega I, mean of the modulated wave, new wave which is formed. There's omega. It is omega of that wave, the new wave. So theta becomes, substituting omega I here, so integration of cos is sin omega st over omega s. This is the integration of cos omega st, right? So delta omega upon omega s sin omega st. So this is called modulation index. Denoted by MF. M mean modulation index, F mean it is frequency index. Okay. So this is the resultant theta. So FM voltage signal becomes, substituting theta here, so this is the voltage signal of modulated wave, new wave which is now formed. Okay, this is the resultant FM wave. MF is the modulation index, and it is ratio of maximum frequency deviation, okay, to the maximum frequency deviation to the frequency of the modulating signal. Because delta omega upon omega s, MF equals to delta omega over omega s or delta f over fs. and maximum is this. Okay. Now advanced mathematics shows that FM spectrum will have many frequencies. Many frequencies mean FC and then FC plus minus Fs, FC plus minus 2Fs and so on. And upper side frequencies are in the plus values, and lower side band frequencies in the minus values. This is an exercise for you, like to search out what about the amplitude of these many frequencies, like Fc plus Fs, Fc plus 2Fs, what about the amplitude? Now next, if the carrier frequency is 1000 kHz, modulating frequency is 15 kHz, then upper side frequencies, there will be like these values. Okay, there are many frequencies. But the question is, what about the amplitudes? That's exercise for you. And the lower frequency, lower sideband frequencies are, okay. Thank you.